The HashCode method in Java is used to get the HashCode value of an object. The HashCode value is an integer value that represents the state of the object. It is used by data structures like hash tables to efficiently store and retrieve objects. The default implementation of the HashCode method in Java returns the memory address of the object. It is recommended to override the HashCode method in classes where the equals method is also overridden. The HashCode method is a public method that returns an integer value. It should be implemented in the class to override the default implementation provided by the object class. The logic for generating the HashCode value should be implemented inside the method. The HashCode method in Java is used to generate a unique identifier for an object. It is often overridden in custom classes to provide a more meaningful implementation. The HashCode method is used together with the equals method to determine the equality of objects. It is important to implement both methods consistently to maintain the contract defined by them. When overriding the HashCode method, it is recommended to use the same fields as the equals method for calculating the hashcode. The hashcode should be based on immutable fields and handle null values properly. Combining hashcodes of individual fields is a common approach. The hashcode method can be overridden as follows. First, initialize a result variable with a prime number, e.g. 17. Then, for each field used in the equals method, multiply the result by a prime number, e.g. 31, and add the hashcode of the field. Finally, return the calculated result. The equals method in Java is used to compare two objects for equality. By default, it compares the memory addresses of the objects. To customize this behavior, you can override the equals method in your class. The equals method should be reflexive, symmetric, and transitive. It should also handle null input parameters gracefully. If you override the equals method, you should also override the hashcode method. Here is an example of overriding the equals method. Public boolean equals object obj. If this equals obj, return true. If obj equals null, get class equals obj. Get class, return false. My class other equals my class obj. Compare fields for equality, return this. Field 1 equals other. Field 1, and in this. Field 2 equals other. Field 2. The hashcode method in Java returns an integer value that represents the hashcode of an object. The equals method in Java checks if two objects are equal based on their content. In some cases, the hashcode and equals methods may contradict each other. This can lead to unexpected behavior when using these methods together. For example, consider a class where the hashcode method only considers a single attribute for generating the hashcode. If two objects have the same value for this attribute, their hashcodes will be the same. However, the equals method may also consider other attributes for equality comparison. As a result, two objects with the same hashcode may not be considered equal by the equals method. This can cause issues when using hash-based data structures like HashSet or HashMap. To avoid these contradictions, it is important to ensure that the hashcode and equals methods are implemented consistently. Both methods should consider the same set of attributes when determining equality. Additionally, the hashcode method should generate unique hashcodes for unequal objects to avoid collisions in hash-based data structures. In this code snippet, we have a class named myClass. The hashcode method only considers the id attribute for hashcode generation. The equals method, on the other hand, considers both id and name attributes for equality comparison. This creates a contradiction between the hashcode and equals methods. Two objects with the same id but different names will have the same hashcode but will not be considered equal by the equals method. To maintain consistency between hashcode and equality, both methods should consider the same set of attributes. When implementing the hashcode and equals methods in Java, there are certain best practices to follow to ensure correctness and consistency. The hashcode method should produce the same hashcode for equal objects. The equals method should be reflexive, symmetric, transitive, and consistent. The hashcode method should combine the hashcodes of all relevant fields. Using only a subset of fields can result in collisions. When implementing the hashcode and equals methods in Java, it is important to use all relevant fields. Here's an example implementation of my class that overrides both methods. The hashcode method combines the hashcodes of my field and my string. The equals method checks if the objects are the same instance, have the same class, and have equal my field and my string values. In Java, every object has a hashcode which is generated by the hashcode method. The default implementation of HashCode returns the memory address of the object. The equals method is used to check if two objects are equal. By default, it compares the memory addresses. However, it is common to override both HashCode and equals to provide proper object comparison. These methods are important for data structures like HashMap and HashSet. The HashCode method is important for hash-based collections as it helps to quickly locate objects. If two objects are equal, their HashCode values must be the same. However, having the same HashCode does not guarantee equality according to equals. It is possible to have different objects with the same HashCode value. If overriding HashCode, it should follow the contract defined in the object class. The equals method must follow certain characteristics. It should be reflexive, symmetric, transitive, consistent, and not null. These ensure its proper functioning. The method should compare the instance variables of objects to determine equality. In this example, the HashCode method is overridden to generate a HashCode based on the name instance variable. The equals method is also overridden to check if two employee objects have the same name. The objects class is used for null safe comparison.